Okay, we are going to discuss three-dimensional shapes. We'll be discussing area and volume of three-dimensional shapes. Now, the first one we have here is sphere. So this is an example of sphere. Something like this is a sphere. Your ball, your orange, this is sphere. Okay. Now, area of a sphere. Area of a sphere is 4 pi r square, and volume of a sphere is 4 all over 3 pi r cube. So you should bear these formulas in mind, memorize them, try as much as possible to put it upstairs there. It will help you in solving challenges that pertain to sphere. Okay, now let's go to prism. Now, prism is a three-dimensional shape with uniform cross-section. So what I mean by that is something like this. This is a prism. Why do I call it a prism? Because it has a uniform cross-section. What I mean by uniform cross-section is that the area here is the same as area here. So there is uniform cross-section. So the areas are the same. That is, there is this thing did not reach here and bend and become bigger or smaller. The length, the distance from here to here is the same as from here to here. It's also the same from here to here. So because of that, we say that it has uniform cross section. In other words, the area of this place and the area of this place is the same. So such thing we call them prism. Example of another prism is something like this. This is a prism because it has uniform cross section. The area here is the same as the area here is the same as the area here. So it is not bigger. It is not bigger here or smaller here. So because of that, we say that this thing has uniform cross section. So any three-dimensional shape that has uniform cross section is referred to as a prism. Now this is also prism. This is an example of prism. Something like this is a prism. Now, like your cuboid is a prism. Your cuboid is a prism. Now, we have so many examples of prism. Now, prism, we normally give prism a name based on the cross-sectional area. So if the cross-sectional area is rectangular, like this one, we call it a rectangular prism. So if the cross-sectional area, like I said, is rectangular, this is an example of rectangular prism. We have the one they normally use in physics, glass rectangular prism. Then if the cross-section is in form of a trapezium, like the one we have here, this is also a prism. If it is like trapezium, like this, we call it trapezoidal prism. Then if the cross-section is triangle, like this one, the cross-section is triangle, we call it triangular prism. So this is an example of triangular prism. So we have triangular prism, we have trapezoidal prism, we have rectangular prism like the one I have here. Now, this is a prism also, but we call it cylinder. Cylinder is a kind of prism. Okay, now let's take their areas and the volume. Now, let's go to a cylinder. Now, surface area of a cylinder is 2 pi r h. H is the height of the cylinder. So the height is distance from the top to the ground or to the floor. So distance from here to here is the height of the prism. That is it. Okay, so now where we normally call surface area is just here. This place I'm just touching is the surface area. So this is the surface area of a cylinder. Okay, fine. So when you are asked to find the surface area of a cylinder, meaning that you are just to find the area of this part I am touching, and the formula is 2 pi r h. But when you are asked to find the area of a cylinder when one side or one end is closed, it means that the thing is like this. So like this place is no longer with the cylinder, so it is open here. Now the bottom is closed, so the area of a cylinder when one side is closed is when you are asked to find here the surface area here plus the area of the bottom. And if you watch very well, area of the bottom is circular, so the area of a circle is pi r square. So the area of a cylinder when one end is closed like this one is now going to be 2 pi r h plus pi r square. This pi r square is for the bottom, and this 2 pi r h is for this part I am touching. Now, when you are asked to calculate the area of a cylinder when both ends are closed, or total surface area, when they say total surface area, it means when both ends are closed like the one I have here. So it means to find the area of this place, find the area of this part, and also find the area of this place, which means we have to find here, and here is pi r squared, here is also pi r squared, plus the formula that we have here as 2 pi r h. So area of a cylinder when both ends are closed will now be 2 pi r h plus pi r square plus pi r square. This pi r square, one is for the top of the cylinder, the other pi r square is for the bottom of the cylinder. Then this one, 2 pi r h, is for the side of the cylinder. So if by the time you combine them, 2 pi r square plus pi r square will give you 2 pi r square. So if you collect factor here, because we have 2 pi r, we have also 2 pi r, so you can remove it and now have 2 pi r in bracket h, which is h plus the remaining r here plus r. So this is now going to be the formula for calculating the total surface area of a cylinder. Okay, now for that of a rectangular base. Okay, now rectangular prism is a example. Your cuboid is a rectangular prism. Okay, now how do we find the area of a rectangular prism? Now for us to find the area of a rectangular prism is going to be the sum of the areas of the 6 faces of the prism, because a rectangular prism has 6 faces. So look at the faces 1, this face 1, 2, 3, 4, 5, and 6. So by the time we calculate the area here, plus the area here, plus the area here, plus the area here, plus the area here, and the area here, then we'll get the area of the cuboid, or area of a rectangular prism. Okay, now I label this side if I want to calculate it now. So I want to calculate this first surface, this first face we are looking at now. So this is for me to find the area of this place, because this is a rectangle. Now what you are seeing now is a rectangular shape, and the area of a rectangle is length times breadth, so it's going to be x times y. And if you watch very well, this face and this face, they are the same thing. So the area here and the area here will be the same thing. So we will now have x times y, and it's 2 times, that means 2 times x times y, because I have here and here to be the same thing. So I will just do area is going to be equal to 2 times x times y. So the reason why I'm putting 2 times x times y is because the area here, once I calculate the area here, is the same as area here. Okay, then plus, I am coming to this side now. Now the dimension here from here to here is z, whereas the dimension from here to here is x. So look at it here. So if I want to find the area of this place, it's going to be z times x. okay, or x times z. So it's going to be x times z, x times z. But because this place and this place, they are the same thing, so I will now say times 2, then plus, I am now coming over this side. Now the area of this side is going to be z times y. The dimension here is z and dimension here is y. Look at it here. So this the length from here to here is y, the length from here to here is z. So the area here is going to be y times z. But because here and here are the same, the area here and the area here are the same, I will now multiply by 2. Okay, so from here you see that we have a factor which is 2. 2 is here, 2 is here, 2 is here. So we can collect the 2 and now say in bracket xy plus xz plus yz. Okay, so this is the formula for calculating the area of a rectangular prism or area of a cuboid, the surface area of a cuboid. Okay, now let's look at trapezoidal prism. So trapezoidal prism is a prism that has cross section as what? That of trapezium. Okay, fine. Now if you watch very well, we have, I don't really have the shape, I don't have the solid here, so that is why I have to make the diagram here. Okay, now let's look at the possible rectangles we are supposed to have or see in this shape. Now if you watch very well, we have rectangle A, B, E, H. That is the one facing that side. The one facing this side away like this. The one facing away like this. Then we have another rectangle. Look at another rectangle. Rectangle B, E, F, C. That's the one on top. The one on top of the shape. That is how many rectangles now? 2. Then we have another rectangle. Let's look at another rectangle. We have C, F, G, D, which is how many now? It's 3. We have counted this one 1, the top here 2, this one 3. Then we have another rectangle, the base. That is where the solid is resting on the floor, which is now A, H, G, D. Okay, fine. Now, if we now want to find the area of this trapezium, it means find the areas of all these rectangles that I have just mentioned, and also the area of this trapezium here and this trapezium here, and sum them all. It will now give you the area of the trapezoidal prism. Okay, look at it here. So that means the area is now what I have here. The area is going to be the rectangle, the area of a rectangle A, B, C, D. The area of rectangle, not really rectangle, the area of the shape of the side A, B, C, D. This side is not a rectangle, it's a trapezium. So the area of trapezium A, B, C, D, which is here. Now I said times 2 because the area here and the area here will be the same, because this is a prism. Like I said, prism has uniform cross section. So that means that the area here and the area here will be the same. That is why we're going to have 2 times A, B, C, D. Okay, fine. Then plus the area of a rectangle now, rectangle A, B, E, H. Rectangle A, B, E, H. That's the one facing that way. Then plus the area of rectangle B, E, F, C. B, E, F, C. That is the top of this solid. And also then plus the area of rectangle DCFG, which is a DCFG, the one facing like this. Now plus the area of rectangle AHGD, that is the one in which this body is resting on the floor. Okay, so we have AHGD. So by the time you find all these areas and add them, then that will give you the area of the solid or the shape trapezoidal prism. Okay, fine. Now let's go to that of triangular prism. How do we find the area of a triangular prism? Now in triangular prism, let's check the number of rectangles we have in a triangular prism. I think we should have about 3 rectangles. Okay, yes, 3 rectangles, and they are, look at the rectangle, the first one ABDF, that's the rectangle on the other side. And also we have another rectangle BDEC. Okay, that is number 2 rectangles. Now another rectangle is the one that the body is resting with on the floor. Okay, so which is rectangle AFEC. Now we have 2 triangles, which is ABC and FDE. So if we find the areas of the 3 rectangles we have seen and the areas of the 2 triangles and sum them up, it will now give you the area or the surface area of this shape, triangular prism. Okay, so that is what I have here. I have 2 times ABC, that is 2 times area of triangle ABC. I said 2 times because the area of this triangle and the area of this triangle, they are the same because this is a prism. So once I calculate the area of this place, automatically I have calculated also the area of this place. Okay, so that is what I have here. Then plus the area of rectangle ABDF, rectangle ABDF, then plus the area of rectangle CBDE, plus the area of rectangle AFEC, So if I calculate all these areas and add them, then that is the area of the triangular prism. Okay, now let's look at volume of prism. So we have just discussed how we can calculate the area. We have discussed how we can calculate the area of a prism. Now how do we calculate the volume of prism? Now volume of prism generally has just one formula, and the formula of volume of prism is area of cross section times height. It could be height or length depending on how the prism is standing or lying. If the prism is lying down like this one, then you talk about the length from here to here. From here to here will be the length, so the volume will now be the area of cross section. That is, if you find the area of this place, if you find the area, this is the cross section, if you find the area of this place, then times whatever that will be the length here, will give you the volume. But if the prism is standing like this now, then you talk about the height. So the volume will now be the area of the cross section, which is here, and the height from this. So this is the height. That is why I said that the volume of a prism is just area of cross section times height or length. So for something like something like a cylinder, something like this, now you talk about the height because cylinder is always standing. But something like cuboid, something like rectangular prism, you talk about the length because most of the times they are always lying down. Okay, so when you just find the area of the cross section, multiply it by the length or the height, then that will give you the volume of the prism. Okay, so from what we have discussed now, let's write the formulas of this prism. Now for this one, since this one, the cross section is trapezium, so the volume will now be equal to the area of this trapezium, and area of trapezium is half into bracket A plus B times height. Then this is the area of the formula for calculating area of trapezium, which is this place. Now by the time you multiply it by the length is this place. Now that will be the volume of this prism. So from here I can now say volume is equal to half into bracket A plus B, close the bracket, h times length. That is for this trapezoidal prism. This is for the cross-sectional area, which is trapezium, and this is now for the length. Okay, now for this triangular prism, since the cross-section is triangular, so I will now talk about the area of a triangle. And area of a triangle is half base times height. Okay, half base times height. Then if I now multiply the half base times height times the length of this prism, then I will now get the volume. Okay, so therefore from what we have here, the volume of this triangular base prism will now be V is equal to half base times height times L. Okay, you know, sometimes they might not really give you the height for you to calculate the area of the cross section. They can give you angle instead. Maybe they can give you angle theta and give you the size here. So when they give you the angle theta and give you the size here, you should now use the other formula for calculating the area of triangle, which is half AB sine theta. That is when they give you angle here and these sides, the sides that form the angle. So you will now use this formula in place of half base times height. Just the main thing is find the area of the cross section, multiply it by the height, then or multiply it by the length, then that will give you the volume of the prism. Okay, now let's look at this one. This is now a cylinder, and a cylinder is also a prism. And we say that if you want to find the volume of a prism, you just do what? Find the area of the cross section. And since the cross section of this shape is circular, so the area of a circle is pi r square then times height. So this is now going to be the volume of this shape, which is a cylinder. In other words, the volume of a cylinder is now pi r square height. Okay, fine. Now I would like you to try as much as possible to learn and memorize all these formulas that we have learned today, so that it will help you anytime you see a problem. Okay, thank you very much.